My name is Jose Pedro Lopez, and this is my pseudocode for the EEL 2161 project. The requirements for choice B is shown as on the screen. We have to use multiplication of two matrices, and the user will be prompted to type in the dimensions of both matrices A and B. If the column number of A is not equal to the column number of B, we have to make the user retype their dimensions. And if the dimensions are satisfied, we will perform the multiplication of A times B and show the result on the user's terminal. We'll begin by adding the header files of studio.h, and we will have four variables, which is row A, column A for matrix A, row B, column B for matrix B, and we will have them all defined as an integer. We will have to use a printf and scanf function to allow the user to input the number of rows and columns they would like on each matrices. We will state the matrices with the inputs of row A and row B, and we will have that array called matrix A, and it will be defined as a float function as well. It can be set for matrix B, and we will use if-else statements to determine if multiplication is possible. We will start it with the condition of if column A is equal to column B. We will continue with the following. We will have to state variables I and j as integers, and we will start a for loop with I set to equal to 0, and the condition is I is less than row A, and it will be added one time each time it's implemented. And inside that for loop will be another for loop for j. It will be the same, where it's equal to 0, and it will be less than column A, and it will be added by 1 each time. And we will use the printf function to ask the user to input the values of both matrices A and B. And for the printf function at the end, we will be using I plus 1 and j plus 1 because we started off with 0 on both variables. Once the users have implemented the values in the matrices, we will use another for loop to display it the same way we did it, but instead of a printf and scanf, it would just be one printf, and it will be shown for each row, each values of row 1, column 1, row 1, column 2, and so on. We will start multiplying matrices by creating a float array with both row B and column A, and we will state a new variable k, which will be an integer function. We will use 3 for loops, I, j, and k, and they will all start at 0, and they will all be set less than column A, and they will all be added up by 1 each time it's implemented. For loop I is to begin with, and for loop j is in the brackets of float I. For loop I, and for loop k is in the brackets of for loop. Once all the values are stored, we will display the new array to the user terminal by using the for loop as used before, and we will be cleaning up the coding for that area by using the /n for the printf function and absolute bar to organize the matrices and the coding. We will use an else statement if column A does not equal to row B, and we would first display a printf function message that tells the user that the dimensions are not equal. And I'm thinking of using the do while loop, where the do loop will be around the first printf and scanf function, and then the while loop will be only accessible if row A does not equal column B, and we will end the code there, but we will return to 0 before ending it. The requirements for choice D is that we have to find the solution of simultaneous linear equations for the unknown variables of x, y, and z. The user is prompted to type in the elements for both of the matrices. We will have the script will find the answers by using the Craner's rule and show the result to the user terminal. We are required to find determinants for Craner's rule by using the user-defined function that will return and take multiple dimensional array as arguments. The header files for this coding will start off with studio.h, but we will also include a defined function that we will call determinant in the header. We will continue by starting off with the same four variables as we did for choice B, which is row A, row B, column B, and they'll all be integer functions. Since we weren't given the instruction of asking for the number of rows and columns, we will go based off of the example given to us in an assignment, where row A is equal to 3 and column A is equal to 3, while row B is equal to 1 and column B is equal to 3. We will state the matrices as a float function and have them have an array of numbers of row A, column A, row B, and column B. We will state I and j as integer functions, and then we will create a for loop within another for loop where I is equal to 0 and I is less than row A, and we'll be adding it up by 1 each time. And then for the j for loop, we will have it the same, starting at 0 and j being less than column A, and within the brackets of the second for loop will be we will have a print f and scanf function to have the values of matrix A, and we will do the same in order to get the values of matrix B. We will display both values for A and B by using two loops again, but instead of using a printf function, scanf function, we will just use one printf function that will display all the float numbers from matrix A, and we will repeat the same step in order to show the user the values of matrix B. We will leave space in order to insert the user-defined function that we stated at the beginning, and then we will end the code with return 0, and then we will start a new user-defined function, and which is called determinant. Well, okay, so in a new user-defined function, we will have to find the determinant values for the matrices. So we will have to use the float values of matrix A and matrix B to be inputs of the function. We will use the equation shown in the link that was given on the assignment for the 3x3 matrix of A, and input the values that we need in order to have the results. I will use the user-defined function I'll return the user-defined function into the main body, and then include it into the Kramer's rule to find the variable of x and y. To print the user's results on the terminal, we have to use a printf function, and it will give the users the answers to x, y, and z. We will end the code and have to clean it up as we did with choice B, where we use the /n and the printf function to give it more space between the terminals, and we will use the absolute value bar to organize the matrices, and that's the end of choice D.